Can we start the class? Am I audible?
Sir, we'll wait for 1 or 2 minutes.
Okay, okay.
Yeah, then we'll start. Sir, now you may start. Sekhar sir?
Sekhar sir,
Yes, sir. Yes, sir.
please start.
Yes,
Okay,
yes
okay.
sir, you can start now, sir. Thank you.
Okay, thank you, sir.
जी.
I'm sharing a screen. Is it visible?
Yes, sir.
Okay, okay. Okay, in the previous class, we have discussed about what is computer, the basic functioning of the computer system, and the basic structure of the computer system and the evolution of computer system. We have also discussed about the generations of computer system in the previous class. In the previous class, we have a brief discussion about the different generations of the computer systems from first generation to our current generation, fifth generation of computer systems. In this class, we will discuss about the different types of computer systems which we use in your life, your daily life. We will talk about the classification of your digital computer, not the calculating machine. So I'm sharing you one PPT. That is your classification of the computer system. Computer systems are classified on the basis of your size, your work, and according to the purpose. Computers are categorized into 3 ways according to your purpose, according to your data handling techniques, that is also called your on the basis of your work, and next one is according to your size, that is also called your according to your functional units. So according to the size or according to the work or according to purpose, we will discuss according to on the basis of the purpose. According to purpose, the computer systems are categorized in 2 ways. First is your specific computer systems, specific purpose computer systems, or you can say that special purpose computer systems. And second type of computer systems are your general purpose computer systems. In the special purpose computer system, we can say that these computer systems are especially designed or execute a particular special type of task. The designing of these system depends according to the purpose of your work. According to the user demand, we design the system for a particular task. For example, in the field of navigation, we design the system only for navigation purpose. Or in the field of research, suppose we want to monitor the data through different satellites, through synthetic aperture radars or satellites, either your Sentinel-1, 2. We will use a specific type of computer systems for monitoring purpose. That is one example. For a special or a particular purpose, we are designing a system. So those type of computer systems are called your special purpose computer system. Next is your general purpose computer systems. General purpose computer systems are those type of computer system that can perform a range of tasks. Different type of tasks can be executed simultaneously in the general purpose computer systems. We can perform a variety of tasks, a range of tasks at a time. The general purpose computer system. For example, our digital computer, which we use in our daily life, day-to-day life, those type of computer systems are called our general purpose computer systems. So according to the purpose, on the basis of purpose, we have divided the computer systems into two categories. First one is your special purpose computer systems. These systems are designed to execute, to perform a special type of task. And another type of computer system according to purpose is your general purpose computer systems. General purpose computer systems can perform a range of tasks, a number of different of tasks at the same time or simultaneously. So those type of systems are called your general purpose computer systems. Next is on the basis of your work. That is also called your according to your data handling techniques. How will you handle the data? According to data handling techniques, computer systems are categorized in three ways. These are your analog computers, digital computers, and hybrid computers. According to the data handling technique, as the name suggests, which type of data will be handled in these type of computer systems. On the basis of these data handling techniques, these systems are categorized in three ways: your analog computers, digital computers, and hybrid computers. So first is your analog computers. So an analog computer is a form of computer that use a continuously changeable aspect of physical quantity that measures your physical quantity, physical facts such as your electrical, mechanical, or hydraulic quantities to solve that problem. To model the problem being solved with the help of your electrical, mechanical, and hydraulical quantities. It uses your physical data. So anything that is variable with respect of the time and continuous, that can be claimed under your analog computer systems. So Analog computer systems measure our physical quantities. For example, your petrol pump machine, that is also a system that measures your either your petrol, diesel. By measuring the physical quantity, it gathers that info or it works by calculation that physical quantity. So these type of computer systems are called your analog computer systems. So it is a form of computer that uses continuously changeable aspects of physical fact. That physical fact can be mechanical, that can be electrical, that can be anything physical. These type of computer systems are called your analog computer systems. Next computer systems are your digital computer systems. Digital computer systems normally which works on your digital data in the binary representation data, that is in the form of 0 and 1. A computer that performs calculation and logical operations with quantities represented as digits in the form of digits. All the logical operations, all the arithmetic operations that will be represented as digits. That is our binary representation form. That is your binary system in the form of 0 and 1. So computer is capable of solving problems by processing all the information in the form of your binary representation form in only 2 digits. That is your electrical signals, low and high. Low is denoted with 0 and high is denoted with 1. So from manipulation of the combination of the binary digits, it can perform all the mathematical calculations. It also stores, organizes, and analyzes data on the binary digits in the digital form. So these type of computer systems are called our digital computer systems. So next type is our hybrid computer system. Hybrid computer system, it is a combination of both digital and logical. A computer that processes both analog and digital data. So hybrid computer is a digital computer that accepts analog and converts them to digital and process them in digital form. Your ATM machine that accepts data in analog form and converts it in digital form by processing and processes in the digital form. These type of computer systems are called your hybrid computer system. Next, we have classified the computer system according to the size, on the basis of the size. On the basis of size, you have already know different type of computer systems, which you have already learned in your previous classes. These computer systems are your mini computers, microcomputers, supercomputers, mainframe computers, your mobile phone, your personal PC, all computers, microcomputers, your tablets. These are your computers on the basis of the size. We will discuss these computers. The first one is your mini computers. These computers came into the market in the mid of 1960 in the second generation and was sold at the much cheaper price than the mainframes in the 1960 era. At that time, we use transistors in the second generation computer systems. These were smaller in size, not as a mobile phone, but this was into market in 1960. So later, they became very popular for personal use. First time, the concept of mini computers came in the era of 60s. In that era, it described the smaller computers that became possible with the use of transistors and core memory technology, because in the first generation, the computer systems were very large because of the vacuum tubes. In the first system, we used 10,000 vacuum tubes, so the system was very large. After the invention of transistors, the system became compact. Those systems were called your mini computers. These systems was your mini computers. And microcomputers is small, relatively inexpensive computer. In the technology, in microcomputer, the technology was your microprocessor. Due to this microprocessor, as its CPU, it was much smaller. It includes a microprocessor, memory, minimal input-output circuitry. But in comparison to other systems, these systems are much larger and more expensive because high technology. For example, our tablets, smartwatches, present technologies, devices, all comes under this category. Microcomputers, small gadgets that we use in your day-to-day life, such as your smartwatch also. Next is supercomputers. Supercomputers are the most high-performing systems. Their processing power is so high in comparison to all other systems. A supercomputer is computer with high level of performance in compared to the general purpose of the computer system. The concept of parallel processing makes these systems very high performance systems. The actual performance of the supercomputer is measured in the flops of in millions of instructions per second. And the millions of instructions can be executed in the per second in the supercomputers. Supercomputer is very important in the field of your computation nowadays, because we have a lot of problems which are still running, continuously running, and we don't have any output. So supercomputers actually play an important role in the field of computation. And we have very intensive computational tasks in the various fields. For example, in your quantum mechanics, quantum computing, either you can say real life weather forecasting or any type of climate research, and real-time mapping, any modular mapping, and in physical simulation. Everywhere we use these high processing computer systems. Even in your cryptography, secure cyber security, supercomputers are also used. Next type of computers are called your mainframe computers. These are common called as a big iron. They are usually used in a big organization for bulk data processing. In the bulk data processing in the big organizations, we use mainframe computer systems. Which type of organization? Such type of organization where we use census data processing, either we can say the transaction processing management in the banking field, where we use different types of servers where we use statistics problems, census data processing. Then we use mainframe computer systems. So these computer systems processing is much higher than mini and microcomputer systems. Nowadays, the mainframe computers are far better than in the earlier stage of mainframe computer systems. So we have classified the computer system according to the purpose. According to purpose, computer systems are your general purpose and specific purpose. Then we have classified the computer system according to your data handling technique. How will you handle the data? Which type of data is handled by the computer system? On the basis of your data handling technique, we have divided the computer system in three ways. Right. Then your analog computer systems, your digital computer systems, and your hybrid computer systems. Then on the basis of size, we have classified computer system in many ways. Your mini computer system, micro, mainframe, supercomputer systems, all computers are according to the size of your computer system. Okay. Next is your computer operations, processor operations. How the data is processed in the computer system. At first, what do you mean by data? Can anyone tell me that? What is data? Anyone of you?
Can
What
I
is
see, sir?
yeah?
Data is information which we want to input in our computer system. All informations are data.
Okay. Then what is information? What is the difference between data and information?
Excuse me, sir. I have some question about the classification of computers, and data is just a raw format of information.
Okay.
It
Okay.
needs the process, and it's becoming the information.
Mhm.
And I have some question about the classification of computer.
Okay. Okay.
You mentioned about the servers
Oh
and
yeah.
embedded computers.
Mainframe computers.
No, embedded computers.
Okay. Okay. Mhm.
These are coming under which category? Based on size or based on data handling
No, no.
or
These comes under your according to the size. On the basis of size.
but a server is not just like based on size, it's just performing some functionalities, so why it's coming based on size?
The servers, we generally any computer, either that is your mainframe, that is your server, any type of computer can be used as a server. Okay, any type of
Yeah,
computer system can be used as a server. We can normally do a digital, our PC, we can also use it as a server.
yeah, but we are specifying server for something special, like suppose I'm just storing my data, so I'm just specifying the server for just databases, not for the whole purpose. That is coming under the general purpose that
No,
you are manipulating any kind of calculation, so that can become that becoming under general purpose.
actually, we are classifying the digital computer. Every computer is digital computer. Okay, and every computer can be converted in any other. Okay, according to size, they can categorize mini, which is
Yeah.
mini, macro.
Okay.
Otherwise, any computer can be your special purpose. Any computer can be your digital computer. Any can be hybrid, because all are the classification of computers.
Yeah.
We can,
So why you are categorizing
yeah,
the digital and analog and hybrid under one category? Why you are bringing that?
that is according to your data handling techniques. According to how which type of data a computer can handle. A computer can handle your digital data. It can also handle your analog data. It can handle both type of data.
Yeah, we have size, we have
Yeah.
functionality, and we
Yeah.
have data handling. So
Will-
based on the functionality, which
Yeah.
computers are coming?
Based on based
Functionalities.
based on the functionality, based
Mhm.
on the functions, according to functions, which type of functions I am using, which type of computer system. For
Mhm.
example, as I have told that for the purpose of server, I have used the mainframe computer system. It doesn't mean that uh, uh, for server I cannot use a normal PC. I can also use a normal PC for the server purpose. In my lab, I have also used a normal PC for server. That doesn't
Okay,
mean,
can you use mainframe computers like for the
yeah,
storage devices? Like under you bring that under in one network, like when you are making one LAN.
yeah,
So mainframe computers can be server for that.
yeah. I have just tell that we can use the computer system according to this. Okay. After the class, we will also discuss it. Okay. After completing this. Okay.
Okay, thank you.
Okay. Then next, what was I talking about? About data. What is data? Can anyone tell me what is data?
Sir, I have said that the data is information which we want to input to
Hmm.
our country, our computer, and also
Hmm.
these informations include it should be a text, or also it should be a voice or image, video, and
Hmm.
etc.
Okay, okay. So data can be defined it as a representative of your raw facts. Okay, that is called your data. That is defined as your raw facts, concepts in a formalized manner, which is generally used for your communication, interpretation, or processing by your machines or a human purpose. That is called the data. Okay, data is simply, you can say that, raw facts which are used for your communication purpose, interpretation, processing. Okay, that is data. And information, when we process that data, meaningful data is called information. Information is organized classified data which has some meaningful values for the receiver. That is called information. Information is the processed data on which decision and actions are based. That is called your information. And data can be defined as representation of your facts, your concepts, your instructions in a just formalized manner, which is suitable for your communication, interpretation, for the purpose of your human and for electronic machine. That is data. And information, after processing, what comes out? That is called information. That is organization, that is organized or classified data, which is some meaningful values for the receiver, for the client, for the user. That is called your information. Clear word, meaningful data. Meaningful data, you can say that meaningful data is the information. For the decision of the meaningful data, the processor must be some characteristics. For information, it must be available within time. Information should be available when it is required. That is information. One characteristics of your information. And information should be accurate. Your data can be anything, but information should be accurate because we have processed that data. After processing, it is organized or classified data. It is meaningful for the user side, for the client. Then it is called your information. So information should be accurate and information should be complete. It should also be complete. After that, the data processing cycle will be completed. We have give the input to the machine. We have give the data input to the machine. In the machine, the data is processed. After processing, when the processing is performed, we have found any output. That output, that is your meaningful, that must be meaningful, that must be accurate, and it should be available when it is required, and it must be complete. After these three steps, this data processing cycle will be completed. So data processing is the restructuring or reordering of data, either by user or either by your computer system, to increase the usefulness, to increase the value of a particular purpose. So data processing consists of these three steps. That is your input part, your processing part, and your output part. In the first step, in the first part, the input data is presented in the convenient form of the processing. It depends on the processing machine. Completely that will depend on the processing machine. For example, if we are using a machine, electronic computer systems, we can record the data in different types of input medium. It can be magnetic tapes, magnetic disk, any CD form, anything. Then this data will be processed in the processing phase. In the second phase, that input data is changed to produce data in the more useful form. In the first phase, the data is gathered, that is your raw data. After processing, this data is changed to produce the data in a more useful form. And in the last stage, at the last stage, the result of these processing steps, the particular form of the output data depends on the use of the data. Now we have find out the accurate, complete data. That is called your information. That part is called your information. So during this cycle, the data processing cycle, multiple operations are performed. In these three steps, these operations are your instruction fetch, in which the instructions are fetches. The next is your instruction decode. We decode the instructions which are given in high level language, we decode according to the machine. The next step is called your instruction execute. How these systems are executed. In the first part, fetch part, the processor just copies the instructions data from the RAM. As I have told in the input part, fetch part. Then in the second part, decoded captured data that is transferred to the unit for execution, that is executed. And in the third part, execution part, instruction is finally executed. Then after, the result is then registered in the processor or in the RAM, that is stored, and that it will be either it will be read or write in the memory in the processor. After that, this instruction fetch cycle will be completed. You will also discuss this processor cycle in your computer system architecture in next courses. So the first of the program instructions are stored generally into the main memory RAM. The computer memory is organized into number of cells and each such as a specific memory address. Every cell has an address. So the processor initiates the program execution by fetching the machine instructions one by one from the main memory RAM. The CPU executes these instructions. CPU executes all the instructions by performing these steps, these instruction cycles, these 4 steps: fetch, decode, execution, store. So every step requires a number of machine cycles to complete a part. In this systems, in fetch, decode, and coding system is the instruction cycle. So in the first step, we have fetched the instructions, and then instructions are decoded, and in the next steps, it is executed. In the first part, the processor copies the instructions data captured from the RAM. In the second part, it decoded captured data that is transferred to the unit for execution, and after that, the instructions is finally executed. Simply that is after that final. And after that, this result will be stored in the processor. This is a complete processing cycle to execute a particular instructions. After that, next is your components of a PC, a computer system. Components of a personal computer system. There are different components of a computer system. That is also called your von Neumann architecture of the computer system. Von Neumann architecture. Von Neumann was a mathematician who have developed the computer system architecture. First computer system. In this architecture, it have one input unit, one output unit, and one processing unit. In the first one, That are your components of your computer system. So digital, okay, screen is not visible. Okay, I'm also sharing, wait a minute. Is it visible now?
No, sir.
I've already shared, but
Now it's visible.
okay. Then components. Okay. So digital computer is an electronic device that receives data. So there is a requirement of devices for receiving the data, and it performs the operations. So there is also a requirement of processing unit. After that, it generates output. There is also a requirement of output devices. So all the data processing in the digital computer is done by a central processing unit that is also called a processor. A working memory is used to store data and instructions. Input devices are used to read the instructions, which we have discussed in our instruction cycles, and data to be processed and output devices, output unit that display the result that is obtained after the executing the program, and central processing unit that is also called your brain of the computer system. It is responsible for executing instructions. It controls the coordinates the execution of the instructions. This CPU consists of your control unit, arithmetic and logic unit, and registers. The control unit controls the execution of instructions by decoding the instructions, generating micro operations to be performed by executing the instructions. Control unit controls all the execution of instructions by decoding the instructions and generating these micro operations. It controls all the functions. And all the arithmetic and logical operations, these are performed by ALU. So to execute a single instruction, an instruction, it involves all parts, your control unit, your arithmetic and logical unit, your registers of the CPU. So CPU is known as the brain of the computer system. That's why it is called the brain of the computer system. And input devices are your keyboard, your mouse. These are your input devices. Am I audible? Sorry for the interrupt.
Yes, sir.
Okay. So keyboard, mouse, these scanner, these are your input devices. And your monitor, printer, plotters, these are your output devices. And in the CPU, we also use your memory, computer memory, for swapping in or swapping out of data. Because initially, the instruction program, even the operating system, that is stored in the secondary memory. When it starts its execution, that comes in the primary memory, that comes into the ROM. So memory is used as a working storage for temporarily storing the data and intermediate results that is generated during the program execution. And computer use two types of memories, your primary memory and secondary memory. Generally, normally in everyday language, primary memory is often referred to as RAM. RAM is called. And secondary memory, generally your hard disk, non-removable secondary storage devices, which stores virtually everything on the machine in the secondary storage. So there are different these units or a computer systems or components of the computer systems. The computer system, it works as your data processor, because the main task of the computer system is process the input data according to the program instructions, because we want a meaningful output information. That's why it is often good as your data processing device. Data can be in any form. It can be your facts, figures, stats. It can be your numbers, characters. This data is then processed in the second unit. That is your processing unit. And the programmers write programs for various data processing tasks. So these are different types of your processing units. This architecture, this is also called your von Neumann architecture of the computer system. That is also called your von Neumann architecture of the computer system. Sometimes it is also asked that what is the architecture of computer system? What is von Neumann architecture of computer system? What are the components of the computer systems? All have same answer. This is the complete architecture. One input device, some output devices, memory units. That is. Then in the memory part, in the second unit, the CPU is your brain of the computer system. The role of memory is very important. The CPU is like the human brain. It has memories. That regulates the functioning of all the parts of the body, like a brain. Controlling all the entire operations. It also controls including your input and output devices. So the memory unit is an important component of the computer, where all the data and informations are stored. In which form? All the data is stored in the form of your binary digits. That is in your binary representation form, in zeros and ones form. And retrieved, and we access this data whenever necessary, when we require, then we use it. So computer system use a variety of devices for storing instructions and data, different devices. So computer memory is the place where the computer hosts the data and programs that are in use. So computer memory is a physical device. It refers to the physical device in a computer. Our computer's CPU constantly access the hard disk to retrieve every data, because initially all the data is stored in the hard drive, in the hard disk, in the secondary memory. So every time the swap in and swap out concept is on. This work is done by your dispatcher. When the data and information is kept in the memory, the CPU can access much more quickly. So CPU is constantly using the memory system. It is continuously accessing data from the memory, and after successful execution, it is either reading or writing the output in the memory. So continuously swap in and swap out process is going on. So the act of entering data in the storage location is called your memory write operation. And the retrieving data from the storage location, that is called your memory read operation. When we write the data, that is memory write operation, where we are entering the data in a specific location, because every location has a specific address, and we are entering that data in the particular storage location. That is called your memory write operations. And when we are retrieving the data from a storage location, or that is called your memory read operation. So data and instructions are moved to and from memory. So data and instructions both can be moved from memory in and memory out. This is called your swapping of data, control signals. So memory is very important component for computer. So memory can be any size. Smaller size primary memory, which have high access time. So a central processing unit in computer system is extremely fast devices as compared to the main memory. For execution, it requires high processing. It depends on the main memory that sends data and instructions when required for the processing. Computer memory can also be a volatile and non-volatile characteristic. Non-volatile memory means it's a type of computer memory which will remain in the stored information if we power, if we switch off the system also, even if the power is shut down, then the instructions, then the data will be remain in the memory. This nature is called your non-volatile, such as your ROM memory, your flash memory, your optical disk. That is non-volatile in nature because data will be stored after shutdown also. And in volatile, when power goes off, it loses all its content. That is your RAM part, random access memory. This is one type of your memories, one type of your primary memory. When the computer is shut down, everything contained in the RAM is lost. That nature is called a volatile nature. So memory can be either your volatile or that can be your non-volatile. And we want that our system, our computer memory, our CPU must not be idle for a long time, must not be idle for a time. Actually, we have not a lot of time to execute. We have a huge amount of space, but we have not so much time. We don't want that our system will be idle for a long time. So there is a requirement of high processing memory. So to reduce this idle time of the CPU, we don't want that system, the CPU will be idle for a while. So to reduce this idle time of the CPU and to increase the speed of the processing, we require a fast memory because we want a high processing and we don't want that our system will be in the idle mode. So we require a high processing, high speed of processing memory, a fast memory. This can also be used, this can also be done using a large size of main memory. If we increase the size of main memory so large, then the cost will also be increased. The cost of main memory of relatively large size will be very high. We have already seen that the cost of RAM is high. As we increase the RAM size, as we increase the main memory size, the cost will also increase. To reduce the cost of a large size memory, a special type of high-speed memory is used. That is called your cache memory. That memory is called your cache memory. That is used between your CPU and your main memory. Because we don't want to use a large main memory because it is not a cost effective. So we use a memory between CPU and main memory. That is also known as your cache memory. So the cost versus access time is the hierarchy of the computer. So we designed a hierarchy for this. Where that hierarchy is called your memory hierarchy. That is called your memory hierarchy. This hierarchy includes your CPU registers, your cache memory, your main memory, and your secondary storage devices. This categorization is on the basis of your cost. How will you minimize the cost? And according to your access time, which device has which type of access time? According to your access time and according to the cost, we have introduced a hierarchy that is called your memory hierarchy. That depends on your access time, your cost per bit storage. What is the access time? Access time is the time required to locate and retrieve data from the storage unit. As we discussed that reading and read out, write and read. Access time, this is the time that is required to locate and to retrieve the stored data from the storage unit in response to a program execution. That is the access time. Actually, that is the time interval between your read write request and the availability of data, because everything is based on your availability of data. The data is available in the secondary storage, and when it requires for execution, it comes from secondary storage to the primary storage, and this is the time interval between the read write request and the availability of the data. So a fast access time is always preferred. We always prefer a fast access time. And storage capacity, we have discussed that according to the cost per bit of the storage, the amount of data that can be stored in storage unit, a large capacity is preferred. And what is the cost of per bit? It is the cost of storage unit for a given storage. So low cost per bit of storage always preferred. So we use cache memory between main memory and secondary storage. The final goal is to minimize the cost of the system also. The goal is high access time and cost per bit storage must be also less, minimized. So the goal of the goal of this system will be to minimize the cost also, as well as your access time. So according to access time and cost per bit of the storage, we have designed a memory hierarchy. That includes your registers, your cache memory, your primary memory, your secondary memory, according to this access time and your storage. There is one question: in which storage memory system is stored? Operating system is initially stored in your secondary memory. After booting process, after post process, when power or self test is executed, when you switch on your systems, the computer hardware checks itself that all the hardware parts is properly connected or not. If the systems, all the parts are properly connected, then the operating system is loaded from secondary storage to the primary storage. If the hardware parts are properly not connected, then it will not load. Okay, so initially it is stored in the secondary storage. So in the next class, we will discuss our storage memory hierarchy. These are the components which we discuss in this lecture, and some classifications, fetch cycles, and components of the computer system. I think it's enough for today. Okay, we will discuss in the next class. Okay, class? Is it clear?
Okay.
Okay,
Yes,
class.
teacher.
Yeah, good afternoon, learners. So, electricity failure is there. So, he's trying to reconnect in the meeting. So, maybe that after 1 or 2 minutes, he will be back. He's trying his means at his level. So, I think he'll be back. And yeah, as such, today's that lecture part is over, and he will be answering some of the queries of the learner. So if you have any query, then you means remain in the meeting. He'll be joining shortly. And one more thing that I need to share with you, that regarding that mathematics class, that was BCS 12 1 2. So we are taking some other counselor as per your requirement. So I think shortly, means by next week, we'll be able to arrange the classes of BCS 1 2, BCS 12 mathematics. So please wait for that also. And meanwhile, let me tell you again and again, I'll be also writing it on the WhatsApp group, that counseling are only a assistive resource, means it is only to facilitate you. The main thing is that you have to study through the written content at your end through LMS. That is the main thing. Counseling cannot cover entire syllabus. So don't expect that you will be getting you will be able to cover all the things through counseling. Counseling is only a very small part of entire syllabus. Yes, the thing is that you have to go through the content on LMS, and then find out the difficult concept where you need any support. So you can discuss on those difficult issues in the counseling session. So that is the purpose of counseling. Counseling cannot cover all the syllabus, because there are only, in most of the courses, only 12 6 counseling sessions are there. Within these 6 counselings, hardly, I think hardly 20% can be covered. So plan as per that requirement. So just wait for I think 1 or 2 minutes more. Let's wait for our academic counselor. He'll be joining shortly.
Sorry, excuse me, if there is a problem, no problem. We can cover that in next session.
Yes. Yeah, within a minute, I'll tell you whether he is able to join, because some power failure happened at his campus. So
And one another question I had, if you cover those specific issues like topics which are much necessary for us, that will be good. Like now, he had something like components of computers,
okay.
like some classification of computers. These are not required for that he covered to us, because we can study that by our own. Those topics which we can't cover by our own, if he covered that those topics, that will be good. This is just my idea.
Yeah, that is good idea. If you see what you can do, you might have seen the entire syllabus. I have also shared you that what to say, chart of syllabus. So if you some of you can point out which particular topic. See, I think only I think okay, in BCS 12 there are number of classes. I think 10 or 12 classes are there. So if you can point out or write on a paper that you need counseling on these particular topic, then we'll share that particular topics with our resource person, and we'll request him to cover those topics with with priority, rather than covering all the things. So if you have any such topic which require input from counselor, please jot it down on a paper, or you can write in the WhatsApp chat. I will ask him to focus on those topics. So everybody, not only you, everybody, please note that if you people see, because counseling is a limited in counseling you will get a limited time for interaction with the counselor. So if you want that the interaction should be more meaningful, more enriching, then you have to make some efforts. You have to jot down some topics from your syllabus that require more attention. So please do that and share those topics in the WhatsApp group. Is it okay? Okay, then do that, and we'll ask him, Mr. Sekhar Kumarji, to focus primarily on those topics, and he may skip the topics which are easy one. He will tackle the topic which really require counseling support. And let me talk to him. If he is able to join, if he is not able to join, then I will ask you to leave the meeting. Okay.